Hello, class 11th Physics, chapter Motion in 2D, numericals based upon circular motion. First question: an insect rests on the tip of a seconds indicating hand 10 centimeter long of a clock. Find linear velocity, centripetal acceleration. Okay, so first of all, just list down all the formulae related to this circular motion. Okay, here one more thing is there. It is not a quartz clock. Um, its arms are moving um, freely with constant speed. I mean, in quartz clock, uh, they go like this. So each time it is moving, then coming into stop. But there are some clocks also in which uh, arms move with a constant speed. So I didn't mention it here, but I have stated that thing. Okay, so uh, now in this question, first we will list out some of it, like angular velocity. Formulae are 2 pi nu or 2 pi by t, new frequency t time period, v equal to r omega, and acceleration, centripetal acceleration equal to v square by r. We can change the values accordingly, shifting value from here to here or vice versa. So now actually nothing is given in the question except this 1 centimeter long seconds hand. So that will give radius of this circle. Let us suppose this is the seconds hand. Insect is at tip of it. So actually insect is performing a circular motion in a circular path of radius 10 centimeters. So R is 10 centimeter. We will convert it into meter. That is 0.1 meter. First thing is done. Second thing, we know time period of seconds hand in a clock. It is 60 second. So actually here I have to put that angular velocity term also, but to find linear velocity we require that angular velocity. So omega equal to 2 pi by t, 2 pi by 60, that is pi by 30 radian per second. And now linear velocity v equal to r omega. Actually I'm leaving it here, you can calculate it yourself. Sometime it is better to leave the answer in terms of pi. So depends upon you and your teachers. Okay, r omega 0.1 into pi by 30. That will be pi by 300. I hope you people know about this. Meter per second. And now the big one, centripetal acceleration. So it is now we can put two formulae here, either AC equal to V square by R or AC equal to R omega square, whatever is convenient. No problem with that. So right now we have V, so we can put that V square by R. V square means pi square by 300 square by R is 0.1. I am writing it 1 upon 10, so that extreme mean it will be pi square into 10 by 300 square. Now you can solve it yourself, and remember, roughly we can take pi square as 10, so you can calculate it easily. Meter per second is the answer. Okay, there is the question. This is not the question. In a death well, मौत का कुआं कहते हैं जिसे, of radius 10 meter, the performer होना चाहिए, performer riding his or her, otherwise gender bias हो जाता है, bike making 1000 turns per minute. ऐसे बहुत सारे एग्जांपल्स हो सकते हैं. टर्न्स पर मिनट, आई मीन सर्कुलेशन पर मिनट, तो CPS, RPS या CPM, RPM लिखा हो सकता है. तो सबसे पहली चीज़ ये 100 टर्न पर मिनट, या अगर कोई और क्वेश्चन हो उसमें CPM या RPM लिखा हुआ हो सकता है. तो इनफैक्ट RPM वर्ड आपने सुना भी होगा, वो होता है रोटेशन पर मिनट. CPM साइकिल पर मिनट और सर्कुलेशन पर मिनट. तो ये एक्चुअली फ्रीक्वेंसी होती है. तो फ्रीक्वेंसी न्यू इक्वल टू 1000 टर्न्स पर मिनट, इसे सेकंड में चेंज कर देंगे. नाउ इट इज टर्न्स per second, so it will be 100 upon 6, and 100 upon 6 ही रहने देते हैं, क्या पता कैलकुलेशन में काम आ जाएगा. हर्ट्स और पर सेकंड वट एवर. नेक्स्ट, सेंट्रिपिटल एक्सेलरेशन चाहिए. वी नो दिस फॉर्मूला, AC इक्वल टू V स्क्वायर बाई R. V की जगह ओमेगा R रखते हैं अगर, तो इट विल बी R ओमेगा स्क्वायर, क्योंकि R स्क्वायर ओमेगा स्क्वायर होगा, एक R कैंसिल हो जाएगा. ओमेगा ओमेगा 2 पाई न्यू होता है, तो इट विल बी R और 2 पाई न्यू का स्क्वायर, विच इज इक्वल टू R 4 पाई स्क्वायर न्यू स्क्वायर. So R is 10 meter. 10 4 pi square, actually pi square की वैल्यू 9.86 होती है. You can roughly assume it to be equal to 10 to save your time. और न्यू स्क्वायर ये हो गया 100 into 100 upon 6 into 6. आई फेल्ट कि से ऐसा रखने में ही कैंसिल आउट हो जाएगा, पर ये तो और भी मुश्किल हो गया. नाउ व्हाट विल वी डू. 3 5 ज़्यादा बेटर है. 3 5 5 5 से 25, 25 4 ज़ा 100, 100 100 100. नहीं, इनफैक्ट 100 अपॉन 9 हो जाएगा. 100 अपॉन 9 इंटू 10 to the power 4. ये 11.1 हुआ इंटू 10 to the power 4, और एक डेसिमल इधर शिफ्ट कर देंगे, इट विल बी 1.1111. तो राउंडेड ऑफ टू फर्स्ट डेसिमल प्लेस, 1.1 इंटू 10 to the power, ये पावर बढ़ जाएगी 5 मीटर पर सेकेंड स्क्वायर. टोटली हाइपोथेटिकल क्वेश्चन, बहुत ज़्यादा एक्सेलरेशन हो गया. एनीवे, आगे बढ़ते हैं. Alright, an aircraft makes horizontal loop of radius 1 kilometer with speed 900 kilometer per hour. Find its centripetal acceleration. In this question, I'm not going to explain the terms very much. It is simply V square upon R. V square 900 kilometer per hour. Remember one thing, that is multiply it by 5 by 18, or if you know that 18 table, so 18 kilometer per hour is equal to 5 meter per second. So 18 5s are 90, 5 5s are 25. Okay, into 5. 18 5s are 90 kilometer per hour will be equal to 5 5s are 25 meter per second, and it is 900, so 900 kilometer per hour is equal to 250 square upon 1 kilometer, that is 1000 meter. So it is 625 double zero upon triple zero, 62.5 meter per second square. The question was very simple. Until now, questions are very simple. But in addition, they can ask what is the direction of that acceleration. So its direction is toward the center. And here, an important thing I want to tell you. What is the magnitude of average acceleration? I haven't mentioned it here, but average acceleration. So as in circular path, it is always directed toward the center, and each time for uniform circular motion, each time it remains same. So all the acceleration vector will cancel each other. So average centripetal acceleration, average AC centripetal acceleration is 0, so it becomes a null vector. What is a null vector? Just revise it. Alright, cyclist cycling at a speed 36 km per hour in a circular path of radius 80 meter, then cyclist increases, increases the speed by 0.5 meter per second every second. हर सेकंड वो 0.5 मीटर पर सेकंड इंक्रीज करता है. समझिए क्या चीज है ये. फाइंड नेट एक्सेलरेशन. एक्चुअली ये जो सेंट्रिपिटल एक्सेलरेशन है, इसे आप रेडियल एक्सेलरेशन भी कह सकते हैं, बिकॉज इट एक्ट्स अलोंग द as along the direction of radius, and it is equal to v square upon r. If there is constant velocity, constant speed, then this formula holds good, and only this acceleration is there which acts toward the center. In this diagram you can see that. But what if its speed also increases or decreases? If speed increases, then there will be a tangential acceleration also along this way. And if speed decreases, then it will go in opposite direction, this way. So right now it is increasing, so there is a tangential acceleration along the direction of velocity. And actually indirectly they have given this. Every second speed is increasing 0.5 meter per second every second. Change in velocity upon time. So tangential acceleration will be this. Now centripetal acceleration using this formula, this 36 kilometer per hour, it is actually 10 meter per second. By converting it into meter per second, 10 square by r, 80 meter, so it will become 100 upon 80, that is 1.25 meter per second square. Oh, I forgot this. Now there are two accelerations, one tangential, other one radial. Both are perpendicular to each other, so we can use vector addition formula. This will be the net acceleration, which can be obtained by this. Simply the expansion through that vector addition formula, a square plus b square plus 2ab cos theta, but they both are perpendicular, so just a square plus b square, that is ac square plus at square. Alright, so simple calculations ahead. It is 0.25 plus 1.5625. We will round it off, and Now you can find it. After rounding off, it will remain 1.56 plus this 1.81, and its root is somewhere close to 1.3 something meter per second square. Okay, and if they would ask at which direction, so from the radius, from AC, it is at an angle, we can find it by using this. This is AC, this is 80, so this is 80, so this is theta, so tan theta is equal to, this is A, tan theta equal to 80 upon AC. 80 is 0.5, 80 is AC is 1.25, that is 1 by 25. So theta equal to tan inverse 1 by 25 from AC. Alright, so this is the question. This I have given you example of non-uniform circular motion. In non-uniform circular motion, there will be a tangential acceleration also. So that's all. We will do some more numericals in upcoming videos. Bye bye.